Hey everyone, thank you for joining us for the first session of our Python and MCP from local to production series. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speaker for today. Pamela, thank you so much for joining us.
Hello, everyone. Welcome to our Python plus MCP series. This is our first session in the series. This is a three-part series happening this week, Tuesday through Thursday. So today we're going to be talking about the basics, how to build an MCP server with FastMCP, which is the most popular Python way of doing it. Tomorrow, we'll be deploying MCP servers into production, into Azure, and also adding private networking. And then on Thursday, we're going to show different ways of doing authentication, key-based access, OAuth-based access, and using Entra. So we've got lots of great content for you, lots of code samples, and we hope you can join us for the whole series. All of these are recorded, so if you do miss any of them, they are all available on YouTube. Just go ahead and register for the series, and you will get emailed when each video is about to start, and afterwards when the recordings are available. So if you didn't register yet, do it now. So now we can get started with today's topic, building MCP servers with FastMCP. If you want the slides, they are available at this URL here, which we'll put in the chat, so that you can have a copy of the slides. You're welcome to use them as a reference. You're welcome to teach this series yourself. If you've got people that you want to share this information with, do whatever you'd like with it. I am Pamela Fox. I'm a Python cloud advocate, which means that I spend a lot of time trying to figure out how to use Python in order to use Microsoft technologies. And these days, it's all about generative AI and all the new technologies and standards like MCP. MCP is kind of the biggest thing of the last 6 months that's really taken the industry by storm, and we've seen so many people jump on it. And so it's been really fun getting to work with MCP so that we can make the series happen. So today we're going to talk about what MCP is for those of you who are brand new to it, then show how we can build a basic MCP server with the FastMCP SDK in Python, run that server in VS Code, use different aspects of the server like tools, resources, and prompts, debug the server, inspect the server, observe the server, like all these different development tools you can use when you're developing locally. And then finally, we'll point some AI agents at that server and see what they can do with it. If you do want to follow along, we have all of our code samples in this repo here. So you can open that repo locally. You can open it in GitHub code spaces. You can fork the repo, clone the repo. It's got a ton of helpful code in it. We're going to be using this repo throughout the series. So it's actually got quite a lot of helpful code inside. So definitely bookmark that repo and use that as a reference. So let's start off with what is MCP? So before MCP, many of us, we're building these generative AI applications like agents, chat applications, workflows, that sort of thing, right? And a lot of times we want to integrate those applications with other services, right? Like here we might want to integrate with a database or with Slack or with GitHub. And in the past, we would have to build custom integrations for all of those services, right? We're like, okay, we're going to expose our, Slack API this way and expose our database this way and connect to GitHub this way, right? And so that meant every time we wanted to bring these services into a new generative AI application, we had to figure out like, okay, how are we going to bring those services in, right? And this was such a common need that so many people wanted to connect their applications to services in really in a common way. So that's why they came up with the Model Context Protocol. So it is a protocol that says how a model can get context in order to answer questions and achieve tasks that the users wants. This protocol was originally created by Anthropic. They created it just over a year ago. So MCP just had its birthday. Happy birthday. And they created it as an open protocol that they made originally for Claude Desktop, their application. And so you could add MCP servers to, Claude Desktop in order to interface, with different services. But it really became very popular. And now it's an open protocol. It's part of the Agentic AI Foundation. It just joined it like 2 weeks ago. And that is a part of the Linux Foundation, right? So the same people that are, in charge of Linux and making sure that stays an open operating system. Now they've got a foundation that's got MCP inside of it and making sure that MCP stays open and has a good community about it, right? So MCP is the protocol that says, okay, you've got all these external tools and data sources. How can we bring those into our AI applications in a standard way? So now, thanks to MCP, we have that protocol that is the common way that services expose themselves, right? So the database exposes themselves as an MCP server. Slack exposes itself as an MCP server. GitHub has an MCP server as well, right? And then that means any application that understands MCP can act as an MCP client and interface with any of these MCP servers over this MCP protocol. And that has opened up much, a bigger world of possibilities and made it just easier for people to start plugging things into each other. So let's talk about the MCP architecture and some terminology around MCP to understand, how everything's structured. So we have MCP servers over here, right? So these MCP servers, that's something like the GitHub server, right? So the GitHub MCP server, it can expose tools, prompts, and resources, right? Now, tools is what most people think of when they think of MCP servers, right? So with the GitHub server, you would have a tool like add comment to issue or read pull review, right? So different tools in order to do common things, with that service. Now the servers can also expose prompts and resources, and we'll see, what those actually look like when we code them up. But most of you, when you think of MCP servers, you probably are thinking about their tools because that is what the clients use in order to be able to, get the job done. So then on this side over here, we've got MCP clients that connect to servers, and these MCP clients often sit inside what we call like an MCP host. So an MCP host is something like Claude Desktop, GitHub Copilot, even ChatGPT recently added support for MCP in like developer mode. Like I think you get like a big message that says danger, danger, right? I mean, there definitely is a danger, right? Because as soon as you start connecting these applications to MCP servers, you are empowering that application with more functionality, especially if your MCP server is an authenticated server that has access to your own data. So there definitely is a risk whenever you give more functionality to an agent or application, but there's also can be a huge benefit, right? And so that's always the debate a lot with all this new generative AI stuff. Is like, okay, like we can get this huge benefit from being able to customize our environment with all these MCP servers that have access to all this interesting data, useful user data. But there is always a risk that we need to keep in mind there. So there we go. So we have this architecture here. And so, within an MCP host, that host can connect to multiple servers and can use the MCP protocol to communicate with those servers. Now, what actually are MCP clients? So there's quite a long list of them on the Model Context Protocol website, and it gets longer all of the time here, right? So I decided to question, there was just a question about Microsoft Copilot, right? So you can see that Microsoft Copilot Studio is an MCP client, or basically has MCP client ability inside of it. The one that we're really going to be using today is VS Code with GitHub Copilot. Notice how it has, look at all these checks. Do you see all these checks here? That means it is fully compliant with all aspects of MCP. And if you look at most of the other clients, it's rare to see that many green check marks. I'm not sure if there's, let's see if there's any. I think there's one more. Okay, Fast Agent has all the check marks. And that's it. So that's one reason why we're using VS Code. We're also using VS Code just because we love VS Code. But so that's the thing about MCP clients, right? The protocol is actually quite a large protocol now. There's a lot of different parts to it. And so many clients support tools, right? That's what most people think of. They think of tools. And so you see here, every single client here has a check mark for tools. But then there's all these other aspects: resources, prompts, discovery, sampling, routes, elicitation, instructions. And that's where there's a lot more variability in terms of support. But VS Code prides itself in being fully compliant with the MCP spec, with all the parts. Generally, it's one of the first clients to adopt features, and it can be a great developer playground when you're developing your own server and you want to test to make sure a particular feature works. So we'll be using VS Code today in order to test the servers. And with VS Code, you can test your own servers. You can also install other people's servers, right? So if you go to the extensions marketplace, and you can search for, you can actually search at MCP, and that'll get you all the MCP servers back that are in the gallery. These servers, I believe these have all been vetted, being in the gallery here, or at least being in the gallery means they can be kicked out of the gallery if we do detect any security issues with them. So this is one way you can find servers. There's thousands and thousands of MCP servers that you can find on the web as well, but these are the ones that are currently in the gallery, that are fairly popular, and that don't have any known security issues here. So if you're interested in any of them, you can click install, and then you can start using them. So let me install this one. So this is Microsoft Learn MCP server. This is a server that can access learn.microsoft.com, which is where all the documentation is. So it's a really helpful server if you do use any Azure or Microsoft technologies, because it can go and actually look for up-to-date information. So you see there's a few different ones for documentation. Another one that people like is Context 7. That has documentation for a lot of open source projects, right? So very common to install an MCP server that gives you up-to-date access to MCP servers for the latest information about something. So then once you have a server installed, then you can go and actually use that server from GitHub Copilot, right? So you can see here, I've got all the built-in tools, but then I've got servers like Azure MCP. I have that disabled right now. I've got the Bicep MCP server. I've got the Python MCP server. And then here's the Microsoft Docs MCP server. That's the one I just installed. So now I could try something like, all right, does Azure Container Apps support serverless GPUs? What does Learn say? All right, here I'm trying to get it to encourage it to use that MCP server. So one interesting thing is that once you have lots of MCP servers installed in in an environment like GitHub Copilot, then the agent has to decide which of those tools are going to be useful to call. And sometimes the agent might not realize that a particular tool is useful to call. And that is one of the tricky things about MCP servers, right? Like if you add more and more dozens of MCP servers, then you're telling GitHub Copilot, like, hey, you're telling the LLM, like, hey, you've got hundreds of different tools to use. And then the LLM has to decide, oh, which of those tools I'm going to use. So in this case, it did actually use what I wanted to use. It decided to use this MCP server, the Microsoft Docs MCP server, and it passed in this query, and then it got back these results, right? And so this is great because now we get up-to-date information here. So that's how we can use MCP servers, other people's MCP servers, inside a MCP host like VS Code. But what we're going to be doing today is actually building our own and using that inside VS Code. And I know folks are eager for that, and we're going to get into that. So if we're building a server, what are the actual components of an MCP server? So the big component is tools. That is what so many people think of when they think of MCP servers. So for example, the tool that just got called was this searching tool that knew how to search the docs. And you can see for each MCP server, I can expand it, and you can see, okay, this server knows how to look for samples, like search the samples gallery. It knows how to fetch an entire documentation page, and it knows how to search the docs. So with my most recent query, it decided to call this search docs function, and it decides that based off of the name of the function and the description of the function, right? You see when I mouse over here, you can see there's long description of the function. So whenever GitHub Copilot is processing a question for me, it is looking at all my enabled tools, it's looking at the names and descriptions and arguments for them, sending those into LLM, and the LLM is deciding which of those tools are most appropriate to help answer the question, and then calling those tools in turn. And, I was saying, like, sometimes it may not call the server you want. In that case, you can check off everything but that server, but more effective is just to say, like, use the, like, if it's really not using the server you want to use, you can say, like, oh, use Microsoft Docs /MCP server. And at that point, when you call it by name, it's going to do it, right? You can also try changing models, right? Some models are better at tool selection than other models, right? So I generally alternate between Opus 4.5 and GPT-5. They're both quite good at tool calling. But that's something to keep in mind, is that if you're using an agent and you don't feel like it's doing a good job selecting tools and coming up with arguments for the tools, you may want to switch agents and see if it does a better job. So MCP servers have tools. They also have resources, which is like basically like static context that is useful and doesn't require like an argument. And then they have prompts, which are like helpful prompts that users may want to use a lot and not have to write themselves. So now let's actually build an MCP server in Python. The first question is, how are we going to build it? Now, you could build it entirely from scratch by actually reading the specification and adhering to the specification. I do not recommend that. I'm not going to recommend that anybody does that. I think you should use one of the official popular SDKs, right? So the Python-SDK, this is the official Python SDK. It's part of the Model Context Protocol GitHub organization, and it tries to stay as close to the specification as possible. So whenever there's something new in the specification, it gets added to this SDK. So that can be a really helpful SDK. However, what we're going to be using and what I'll be recommending is FastMCP. It is a framework built on top of the SDK. So it has all the functionality that's in the SDK, but it also adds in a lot more helpful functionality, right? So it's got stuff like integration with Entra, which is great for those of us who are using Entra. It's got integration with like 15 other auth providers as well, right? So it's trying to make it really easy to do the most common things that people want to do, like making it easier to integrate with Fast API, making it easier to deploy into production, making it easier to do logging, to do OpenTelemetry, right? So there's a lot more additional features in that FastMCP SDK, and that's why we're going to be using that one, and that's what I'll be recommending. So when we use FastMCP, we're going to be able to write our servers in a very Pythonic way, right? We're going to be using decorators. We're going to use Python type hints. We're going to use async. We're going to be able to get fancy with our tool annotations, and we'll have all the options that we need for building a server. So let's try out our sample server. Now, this is from the repo. So once again, as a reminder, if you do want to follow along with the code, go to aka.ms/python-mcp-demos. That will bring you to this as your samples repo, python-mcp-demos. And that has all the code that we'll be showing today. So let's go ahead and see how we can run a local server. So we already have a server written. It is the first one we're going to be working with is this one, basic_MCP_stdio. And you can see this is using the FastMCP package. So in order to use this server, I'm going to open up the mcp.json configuration file. That's in my .vs code folder. And you can see there's a few different existing configurations, and you can also see a button here to add a server. So if you wanted to add a new server for testing out, you could click this button and it would, go through a wizard to help you add another server to this. Of course, it's also JSON. You can copy and paste and add it this way. So we're going to start up this server here. So you can see that it's going to use UV. UV is a tool for running Python programs and managing Python environments. And it is very popular with the MCP community. So you'll see a lot of use of UV with these local MCP servers, especially. So we're using UV, and it's saying so it's basically going to call this command. So this is what's called a standard input-output server. So it's basically just accepting a shell command and running that command here, right? So it's going to run this command here whenever we tell it to run this server. So we don't actually have to run it in the terminal, because just by clicking start, VS Code ran this command for us. So it says it's already running. It says it's got one tool and one prompt. So that's good. That's what I expected. And now the next step is going over to my Copilot chat and clicking on this little tools menu right here. So when I click on this, I can see all the possible MCP servers that are known. And what I'm going to do is check this one on. So this is the one that we just toggled on, and we can see it has one tool underneath it, the add expense. And so we toggle that one on so that Copilot knows that it can, use this tool. All right. So now it's started. It's got one tool. We can also look at the output. So I like to put up the output window here. So see, if you go to the more, then you see stop server, restart server, show configuration, show output. So it's helpful to show the output sometimes just to see if there's any errors. And there we go. So now let me open this file again so we can take a look at the tool. So this is an expense tracking MCP server. Its whole job is to track expenses. Locally, it's just storing them in a CSV. Once we go to production, we'll store it in Cosmos DB. But for now, we're just storing in this simple CSV file here. And we have this tool here. So in order to write a tool, we use this decorator mcp.tool. So this is what's called a decorator in Python, is when you have at and then the name of the decorator. So we're saying, okay, this function is a tool. And then we can see the function signature, the function header here. It has a name, and then it has the arguments that it takes. So this tool here, this function takes a date, an amount, a category, a description, and payment method. Now, what's important is to look at each of these type annotations. So I could have been really simple and just said date, but then the agent would only know that this, the name and the type. I like to get really fancy and say, okay, it's a date, and it's type date, and here's a description of it, right? So here I said, oh, it should be in this format, right? And with amount, it's a float, and it's a positive numeric amount of the expense. The category is an enum, which is fun. So an enum is a way in Python to have a possible set of values, right? So here we say these are the only possible values that this argument can take on, right? So it's either got to be, one of these 5 values. So that's the, one of those values. There's description. Description is a string, and that's the description of that one. And payment method is another enum. It's one of these values. And there's a description, right? So it really helps to get very specific in your function changer here, because all of this information is going to get sent to whatever application is using this MCP server, right? So in this case, all of that information is going to get sent to the LLM used by GitHub Copilot, right? So it will be able to see the name of the argument, the type of the argument, and the description of the argument. So I do recommend you using annotated types in order to fully describe your tool's arguments. All right, and then it gets in all those args, and and then it processes this code. Now, none of this code is ever exposed to the actual GitHub Copilot's LLM, right? It only sees the description of the function, not how it's implemented. So how it's implemented is, opens the CSV and it writes the file to the CSV. But all that the agent cares about is, okay, what are the tools and what are their arguments? So now what I can do is, once again, I'll make sure that we've got it enabled, and then I'll go here and say okay, I bought a $222 tutu today on my corporate Amex for a conference. Here we go. All right, so here I've put something in the chat that hopefully should trigger the LLM here to think, okay, maybe I should use this expense server, right? And you can see that it's thinking about it, and it during its thinking process, it found the server, right? And you can see here, this is the name of the tool it wants to run. This is the name of the server that we enabled, right? Remember, that's in our mcp.json, right? Expenses MCP, expenses MCP. The add expense matches what's in our actual code. And these are the arguments that it wants to send. Now, the LLM, in this case, GPT-5, is the one that decided on the arguments, right? So it looked at this tool and said, oh, okay, based off the user's query and based off the arguments that this tool expects, I'm going to pass in this date, which is today, this amount, this category, and this description, and this payment method, right? And here we see that it's asking for permission. And that's a nice thing about VS Code, is that by default, it does ask for permission with actions like this from MCP servers. And we have these options here where we have a lot of options, right? We can say allow in this session, in this workspace, always allow tools from expense tracker, right? So tons of options. You can also just always click allow. In this case, I just always click allow, but VS Code tries to give a lot of options for how much you want to trust particular tool calls. So then it added the expense. And if we check our CSV file, we can see that indeed it added the expense here at the end of the CSV file. So once again, that was by how it did that by calling the tool. And so if you wanted the tool to have more functionality, you would, you could change the annotations, you can change the descriptions, right? There was a question about could the date be submission versus billing date, right? So this, you might want to say billing date, right? So basically you keep on, as you see you want to monitor the requests that come in, and you want to see what it gets right and what it messes up on. And then you can decide whether you have to be more specific with your annotations and whether you might need to add more arguments. You can have optional arguments too. You may, that maybe something you want to do because maybe sometimes people specify information. And the cool thing is that since it is an agent, it can also ask the user for clarification, right? So if I say I also bought, a $20 pizza. Now, it's either going to assume that I use Amex, or it could go back and actually like ask me like, wait, what did you buy in that, right? Because that's the thing, we are working with an agent here. Agents can, they can iterate, they can reflect, they can decide to ask, follow up. Now, in this case, I think it decided it was Amex again, so it didn't ask me. But in theory, it could ask if it had any doubt about the arguments. All right, so now we've seen tool, and that's really what we're the real heart of MCP servers right now. But there are other functionalities that we can do as well. So let's check out resource. So here is the resource. This one we've decorated with @mcp.resource, and we've basically come up with a URI for the resource, and we say, oh, this is the resource we're exposing here. And all this is doing is reading in the entire CSV and just returning it, right? And the interesting thing here is that now we can basically refer to this as a static document. So that resources could be useful for servers if there's kind of like documentation attached to them that people might just want to add to their conversation. Now, the way that you actually do it is you go to this little button here. So right now it's a paperclip. Sometimes it says add context, depending on whether you already have context, right? So here I already have context, so it's now a paperclip, but it's basically the add context button. And when you open it, you can see all the possible context sources that VS Code can use. And so one of those is MCP resources. So we select this, and then we can see the resource, and we only actually, we have a few. Oh, look, there's also ones exposed by the GitHub server. So the GitHub MCP server does also expose resources. That's, I think, the only other MCP server that I've seen that exposes resources, but but that can be helpful. So here, I'm going to select this one. And so it basically just attaches it to the conversation, right? And then I can be like, okay, analyze my expenses and tell me what's the biggest expense. Right. So now I can ask that question because I know it has this expense information attached. Now, in reality, I probably wouldn't have a resource like this for an expense tracker because expenses, it feels like getting your expenses should be more of a tool than a resource. But it's something you can use if it makes sense for your server to expose resources. And here we go. So it analyzed it and answered the question, right? The next thing that we can do is a prompt, right? So prompts are helpful if you're, if you find that users are commonly doing the same things over and over with a server, and you just want to make it easy for them to, just be able to just run a prompt and it'll just do it, right? And prompts are interesting because they can also be templatized optionally if you want. So this prompt will do this analyze spending patterns thing. So the way to trigger a prompt is you're going to say /. And when you do /, you see all the possible prompts that are exposed by your other MCP servers and extensions. So here I'm going to select the one from the current server, which is this one, expenses.mcp, analyze spending. And it pops up asking me for possible values for these arguments here. But these are all optional. So I can also just go like this, enter, 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 and boom. So here's the prompt. And now, so now I've got that prompt and it's doing a little analysis now based off that prompt. And, it's got access to the expenses still from this conversation. And it's doing a lot of thinking here because we asked it for a big old analysis. It says it's all set, reviewing. Oh, now it's going through each of them. I thought there's a question, can a resource be implemented as a tool? Yeah, so interestingly, for the subsequent sessions, I did actually turn this resource into a tool because I just felt like, especially once we added user authentication, it didn't make sense for it to be a resource anymore because it needed to be user specific. So I turned it into a tool. So I think most of the time you want to expose everything as a tool, there may be some additional things that it makes sense to also expose as a resource. But I think because most people don't know about resources, it's kind of a chicken age problem. Like most people don't know about resources and that you can actually, easily attach MCP resources to a conversation. So given that most people don't know about resources and that they're not exposed to the agent, that's why I would tend to always expose everything at least as a tool, and then maybe add on some resources as well if you've got, super users that are actually using them. All right, so then we got a big old analysis here based off of that prompt. Okay, so there we have the local MCP server working with tools, resources, and prompts. Now, keep in mind, this is a very simplified server in order to show something working locally, just saving to the CSV. In the subsequent sessions, we will, actually save it into a Cosmos DB production database, and then we'll even add user authentication so we can tie expenses to user IDs, to like their, Entra identity or other identities, right? But this is to show you the basics of how you would set up a FastMCP server. All right, so we saw tool, resource, prompt. Now, this server was running using standard input output, right? So if you remember that mcp.json, we were using UV in order to run that Python command. So there are many servers that run locally using stdio, if they're a Python server, it's usually UV run. If they're a JavaScript server or TypeScript server, it's usually a npx command right here. You might see npx. Instead, like for the Playwright server, that one uses npx. So that is what's called an stdio or standard input output. And basically like anything that you can run with a command in a terminal, that's a standard input output server. So this can be really helpful because, as long as you can run it locally, then you can run the server. However, that does mean you have to be able to run it locally. And I will tell you that for me, like, okay, my UV is working correctly here. But I had an incident last week where in like VS Code Insiders, I couldn't use UV, like the path wasn't right. And then I tried to install the Playwright server and then my NPX was wrong because of NVM install and blah, blah, blah. So like as soon as you're requiring like commands to work, that means people have to have an environment that supports those commands, right? So it means my, my Python install has to be correct. My UV install has to be correct. My node has to be correct for the npx ones, right? So there is a bit of a barrier there that can happen when you're using stdio. And, and so I think it's great to get started with, but generally I prefer HTTP servers, and definitely for production, I would recommend an HTTP server. So that's what I'm going to show next, is how can we run an MCP server basically as like a proper server over the HTTP protocol. So what does this actually look like in the code? So if we go to the this other file, basic MCP http.py, what you'll see is at the bottom, when it calls mcp.run, it's defaulting to the HTTP transport instead of the standard input transport. So you can see the options are stdio, SSE, or streamable HTTP. SSE was the original, an original HTTP option, but it's kind of been deprecated in favor of streamable HTTP. So that is what this one wants to run over instead, right? And the rest of the code is pretty much the same. It's really this last line here that's different. Now, the next steps that different is that we do actually have to first explicitly run this file and get the server running, because VS Code isn't going to know how to run the server. So we're going to say uv run servers basic mcp http.py. And okay, let's see. I was trying to, let me take something out of the .env here. Okay. Boop. I'm just going to restart that server. Okay. All right, let me rerun it here. Okay, so we can see that the server is starting HTTP mode on port 8000. So now this server is running at localhost 8000/MCP. And we can see that here. It says here, this is where it's running. So now it's running at that URL and it is ready to receive MCP requests. Let's see, if we go in the browser, we'll just get an error because it's expecting to get a properly formatted MCP request, but we do see that it is running something at this port. So then how we use it is we're going to stop the server we were using before, the standard input output server. Then we're going to start this one here. And this one, you can see it says type HTTP and URL. So all VS Code knows is that this is an HTTP server running at this URL. It doesn't know how that server got started. This server could be written in JavaScript, C#, Python, whatever, right? All it knows is that there is an MCP endpoint at this URL ready to accept MCP requests. And we can see it did find that it has one tool and one prompt. So now I'm going to start a new chat here. I'm going to open up my Copilot tools. I'm going to deselect the old server. And now I'm going to select the HTTP server and then say, okay, I got a $200 seafood platter on my Amex today. Okay. So hopefully, and we can also watch, now they're running the server, we can actually watch MCP requests going over the server here. So you can see there's lots of JSON being sent to this MCP endpoint here, different, get, post, delete, etc. So here we go. And this time you can see it selected the expenses MCP HTTP server instead, right? Because we stopped the other one. Let me stop this one too. And so now this is the one running and this is the one enabled. So we're going to say allow, and now we can see the logs in our server. And so we can see that it successfully added it using the server. So this is a server running over HTTP, and this is what generally recommend, and definitely what we'll be using when we deploy these servers into production for the next 2 sessions. All right, so now let's look at a few development tips for MCP servers. So the first one that I think is really cool is that in VS Code, we can actually do breakpoint debugging. I don't know how many of you use the breakpoint debugger, but I love the breakpoint debugger when I'm having some really, really thorny issue. And I just want to see what happens at every single, line in my program, right? Like, how do the variables change? That's the big benefit of breakpoint debugging. So, so what's cool is that you can do breakpoint debugging with VS Code servers. You have to add a configuration. We added a configuration for that in launch.json so that it can attach to it. So in order to show this, I'm going to stop these servers. I'm going to start this debug server here because we're starting it off in a special mode where we're enabling the Python debugger. And so here I'm doing it for the standard input output server, but you can actually do it for HTTP servers too. All right, so we can see this one is running. And then what I do is I open this up and you can see I've got breakpoints. So breakpoints is where you want the debugger to stop. So I can add a breakpoint to any line where I want the debugger to stop, right? All right, so now I've got breakpoints. Then I go to the debugger over here, and you can see there's one debug configuration. So I start that up, and that starts the VS Code debugger. And now that is running. And now we're going to go here and check to see that we have the debug one enabled. Okay, so everything's sorted. We've got breakpoints. We've got this one running. We've got the debugger started. And we've got the right one enabled over here. So now I'll be like, okay, I got 300 of pizza today on my Amex. Okay. Just so much pizza. Oh my gosh. I never want to see pizza again after this. All right, so it is deciding what to do here. And it's decided what to do. And we're going to say allow. And then what you can see is it immediately popped me into the file. So we are now in debugging mode. And in debugging mode, you can see the values of each variable as you go along. So we can see what the values were of each of the arguments as they came in, which is super cool. We can see the variables over here. We can, dig into them. We can watch variables if we want to. So basically everything that you expect out of a debugger, we can do that here, right? And now I can step line by line. I can watch as things change over time. I can jump forward to the next breakpoint. And yeah, so I'll just press continue and let it finish. So that's really neat. I always like to encourage people to set up a breakpoint debugging so that it's easy to do. Because here's the thing is that when you actually run into a bug, you're going to be like too frustrated to be able to set up breakpoint debugging at that point because it does require a little bit of setup. So I always think you should set it up like with your, launch.json and configuration, like get it all set up when you're in a good mood so that when you're dealing with a bug, you can use breakpoint debugging and it's already set up for you. Okay, so that was breakpoint debugging. I'll detach from that now. I'll stop this server. I'll go ahead and restart the HTTP server. And let's see what else we can do. So here's another helpful tool. This is called the MCP Inspector. It is a user interface that makes it easy to interact with MCP servers, without having going through an agent in front, right? Like I've been demoing everything with, GitHub Copilot, but that's adding, another layer on top, which is the, the Copilot agent and LLM, right? You might want to just directly play with your server using this inspector here. So we're going to start up the inspector. And I'll just go. We also have all of this described in the README too. So I'm just going to go to the README to make sure I follow the right steps. So we've got the server running, and then I'm going to run this inspector. Here we go. Need to install. Oh, they must have just released today. I installed the latest version like last night. All right, there's a new version. Great. Good. Okay, so now it starts up. We're going to say connect. It is now connected to my localhost MCP server. And now you can see I've got resources, prompts, tools, sampling, elicitations, roots, auth, metadata, like all these different aspects that your MCP server might support. Now the fun one, of course, is tools. So we can see we have this add expense function. And so we can go through here and say, okay, it was 25, 12, 12. It was, 365. It was food and it was pizza. So tired of, we'll just say pizza. And it was Amex. And then we're going to run the tool and we can see success. And you can see a history of all the tool calls here. So this is a handy way of, working with your MCP server when you're developing it and, just having an interactive UI where you can test it out. So that's the MCP inspector. You can check the README for, more details on setting it up. Now, there was a question about observability in the chat a few minutes ago. So observability, what does that even mean? That means being able to see what our servers are doing, like seeing the requests that come into them, seeing their log, seeing like the fact that they made a request to another service, like a dependency, right? So we call that all of that observability, right? And it's usually a combination of logs, traces, and metrics. And we use this standard called OpenTelemetry, which is all these standards around how we observe our applications. Now, we're going to talk a lot about observability in tomorrow's session because observability is so important when you put servers into production, because you want to know what the heck your servers are doing and how people are using them. But you can also set up observability with OpenTelemetry locally as well. So we're going to do that using Aspire. Aspire actually comes from the .NET community, but they are trying to bring in the Python community as well. So that's why we've set it up today, so you can check it out. The way we're going to do that is, let me quit the inspector. So first we need to start the Aspire dashboard, and this is just a Docker container. So I'm going to do Docker run, and I need to start up my Docker. So let me start up Docker locally. And here we go. We can see the little whale is starting up here. And it's installing an update. Not the right time. Don't do it. Okay. All right. So we've got Docker running. And so now I'm going to run Docker run. All right. So now it's running. So if we look at Docker, you can see I do now have the Aspire dashboard running, and it's running on this port here. And then we're going to get the link to the dashboard. So I'm going to open that up here. So there's the dashboard. This is a locally running dashboard. And then we're going to make sure that our server is exporting to that endpoint. So I'm just adding this endpoint to my .env. And then I'm going to run the server. And if you look at the server, you can see at the top, we do actually check to see if that .env, that m variable is defined. And if so, we set up the Aspire dashboard and we use some middleware in order to trace the OpenTelemetry. So we will talk more about that middleware tomorrow, but we wanted to show Aspire for the local use case today. All right, so now I'm going to restart the server since we did change that environment variable. And so I want to make sure it is restarting with Aspire. So we can see it's setting up Aspire dashboard. Great. Okay. So now it is running, and let's check. See, so we've got our HTTP server running. We're going to go over to Copilot and check to see what's running over here. Okay, let me put HTTP server on, and let's see, I bought a $22 tutu today on my Visa. All right. So we're hoping that it's going to send this call out to the HTTP server. Okay, and we can see there's already a log that says the server was starting. So we can see that the Aspire dashboard is already getting at least the logs from the application. All right, and it wants to call the HTTP server. So that's good. We're going to say allow. And then we're going to go back here and boom. So here we can see the log that came from logger.info. But what's really cool is that there's an attached trace. So we can click on this trace, and this is a OpenTelemetry trace. And it has all this additional information here, all this metadata that came from the tool call, right? So you can add all sorts of logging and traces when you're using, when you're adding observability to your app. And we'll add even more to this in tomorrow's session. All right. So now you've seen how to build FastMCP servers locally using both standard input, output, and HTTP, and our favorite debugging tips and developing tips forum. Now we want to show how you can point AI agents at those MCP servers. Because so far, I've basically been using GitHub Copilot as my AI agent, which is great. And that might be, why you're building your MCP server. But many people are building MCP servers so that they can use them as part of their agent orchestration, as part of their agentic workflows. And have, like, within a company, you might expose some functionality as an MCP server. And then you might have multiple agents in that company that are interacting with that server. So what does that look like? We've got a couple examples for you in the repo. The first example is using Microsoft Agent Framework. That is our newest AI agent framework, and it is the successor to AutoGen and Semantic Kernel. So if you were using AutoGen or Semantic Kernel, you should move on over to Agent Framework. It's got everything, basically everything from those, plus way more. And it does have built-in support for MCP servers, basically using them for tools for an agent. So we have a full example in the repo, which is this in the agents folder. You see this agent framework /HTTP. So you can see this brings in the agent framework, and then it connects. Now we need an LLM because we're actually, we're making an agent. The agent needs an LLM to decide which tools to call. So here we've got support. You can either connect it to Azure, and that's what I'm doing because I've got a deployed Azure endpoint, or you can use GitHub models as long as the model supports tool calling. Or you can use Ollama as long as the model supports tool calling, which that's a harder task, but there are some good ones. I think also Quen and Gemma would be ones to try. Or you can use OpenAI.com, right? So you can configure these agents to use your LLM as choice as long as they support tool calling. Then we set up the MCP connection here. So we say, all right, here's the server, here's the URL. This URL is defaulting to the localhost URL, but we could also point it as a production deployment version if we need to, as we will soon in the next sessions. Then we set up an agent and say, okay, this is our agent. This is the system prompt for the agent. And then when we run the agent, we're going to give it give it access to those MCP server tools, right? Say, okay, here's the query. Here are the tools you can use. How are you going to use those tools to answer this query? So let's go ahead and run this example here and see how it does. All right. So right now it should be sending all this information, connecting to the LLM, sending this information to the LLM. And interestingly, it actually, it wasn't sure how to categorize the laptop purchase. And so it actually asked me, would you like to log it this way? So it actually didn't log it because it was so unsure, which is interesting because last time it was fine. I'll just give it more information. So that's the thing, like normally when you're using agents, you're typically going to have them, having some sort of a human in the loop or some sort of way that you can give feedback to the agents about whether, it's done the correct thing. And then we'll log it again. So we'll see if this time it understands well enough to do it. So there we go. So this time it successfully logged it under, the gadget category. And we can see it is in that CSV. So here I was able to use that. And the cool thing is that you could, I saw a question, can you have multiple tools, multiple MCP servers? Yeah. So this is, here I'm just giving it access to one MCP server, and that MCP server has one tool, but your server can have multiple tools. You can give it access to multiple MCP servers, right? You can do all of that because you can send like hundreds of tool call definitions to an LLM, like as long as it has a big enough context window for it. Now, you do always risk that the more tool call definitions you send, the more likely an LLM is to get confused. So you do want to make sure it's like really unambiguous what each tool does, but you do totally have that option. Now, we also have a Langchain example, and that's quite similar. It's setting up the connection. It's connecting to the MCP server. It's passing the tools into the agent, and then it's sending the same query to the agent. So here, let me run this one. Let's see, this is HTTP. Okay. So we just want to show that, basically, if you're using an agent framework, all of the modern agent frameworks have built-in support for MCP, where they're acting as an MCP client, right? You can see here it actually calls itself a client, right? So the agents can act as a client. They connect to servers, and they have ways of passing, some way of passing the MCP server's tools to the agent. So here you can see that Langchain successfully logged it as well. So now we should see another laptop purchase here. So there we go. And that brings me to the final slide right in time. That is what I wanted to show today for our first session of the series. We do have, in a few hours, there's going to be a Spanish version of this session. So if you do speak Spanish or have any friends that do, Gwen will be leading that session. Please point them to it. The recording for this will be on YouTube pretty much immediately, so you can rewatch it or share it. We'll also be linking all of the resources from this thread here, this link here, this Python MCP/resources link. That's where I'll put all the slides, recordings, code samples, etc. And we have this tutorial that our colleague wrote, Chris, MCP for Beginners, that you can go through as well if you want another way of learning after this series. And every single day of this week, we are running office hours after the session, which means when I close this stream here, I'm going to hop into Discord and start up an office hour sessions, because I know there were lots of questions that we didn't get to. And so for this week, after every single session, we are going to be running Discord office hours to try and tackle as many questions as we can. So basically, I will end this YouTube session and then jump over to the Discord and hope to see lots of you there with all your questions. All right. Thank you so much, everyone. Thank you so much for joining. And I do hope to see you in the Discord. Just double check that we're put the link in the chat. Let's see. Can we get the link in the chat? Do we get it here? We also flash it up on the screen. We'll make sure it'll be there soon. It's also linked from the resources. I link to that just everywhere. If you go to my GitHub, you always find the office hours there, because we always hold office hours every week. But this week is a special week where we have Discord office hours every single day of the week. Boop. All right. And I see the link is in the chat. All right. So we are good to close it up here and head on over to Discord. Thank you, everyone, for all the kind words in the chat. It seems like that you like the session. That's awesome. And I hope to see you for office hours. Bye, everyone.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.